we're going to add that the way that you want to build your fence, because here's your river. Ooh, even drew it in blue. And you're going to want to make a rectangular fence, but you're going to want your fence to have a partition in the middle.
Do you want your fence to go all the way?
Well, it's just going to go up against the river, but now you're going to partition it off because you're going to put, what animals are we taking care of? Crocodiles and chickens. Very good example, right? The only problem with crocodiles and chickens is the crocodiles could probably still swim in the river and the chickens could fly out of the fence. So not the most strategic, but you hadn't thought that through. So here's our plan. We're making a fence for crocodiles and chickens along the river. We haven't quite figured out that crocodiles can swim. I'm sure we'll have to redesign afterwards anyways, but you start with the math anyways. That extra partition changes things. I'm adding, it's not in the question, but because the numbers are exactly identical to the one we did yesterday, I thought I would throw this in there so that we can see how would we solve this now with this added bit of information.
So is that partition included in the 80 feet?
It would have to be, right? Because if you don't include it, then they would just eat them right away. And you at least know that wouldn't be good, even though you haven't thought about the river and the crocodiles. Okay. So what did we do with well, we want to find the maximum area, and you know that area is length times width. And one of the things we did last time is we just threw out some possibilities, right? One possibility, not a very strategic one, could be 1, 1, 1, right? That's 1 foot, that's this long. And how long would be left for here? 77. That's one possibility. The area of that would be only 77 feet squared, not very big. Can you see that if you made this bigger, like 10, 10, 10, how much would be left along the bottom? How much? 50, right. So that would give us 500. 500 feet squared for the area, much bigger than 77. Can you see that each time you do this, you're putting in numbers here first? So that makes sense for us to call those x, x, and x. How much is left? Yes? How much would be left along the other side? In terms of x. 80 minus 3x. That's what you did every time with numbers, so you do the same thing with algebra. So now our length is 80 minus 3x, and our width is x, and we can complete the square. Multiply it through. Ooh, we're going to get some fun fractions. This is good practice with fractions. Fractions don't suck. They're just a little bit more work. It practices those skills that you learned in grade 7 and grade 8. So it's not bad. Take out a negative 3. That would leave you with x squared. Taking out a negative 3, factoring out a negative 3 is like dividing. And so I would be left with 80 over 3x. Leave your spaces. What happens when you do 80 over 3 divided by 2? You get 80 over 6 or 40 over 3. You okay with that? 80 over 3 divided by 2. Dividing by 2 is the same as multiplying by a half. Half of 80 is 40. You'd get 40 over 3 and then you would need to square it.
Excuse me.
Hello?
I'm sorry for interrupting. Could you please have Ben Zhang move to the office for a quick moment, please?
Okay, he'll be right down.
Thank you.
So then we would get plus 1600 over 9, because of 40 over 3 times 40 over 3.
Why do you have to make such ugly fractions?
This is just a real life example. Why would you put chickens and crocodiles that close to each other? Right?
Maybe we want to see a good show.
Now what happens now? Again, it gets multiplied by the negative 3. So you've actually subtracted 1600 over 9. Times by a negative 3 would be 1600 over 3. So the opposite would be adding 1600 over 3. And now we have
I like decimals. I don't know if you don't like decimals.
no, this would be awful with decimals. Okay, 80 divided by 3, what is that? 26.6 repeated. Okay, do 26.6 repeated, divide by 2 in your head, you get 13.3 repeated. 13.3 repeated squared. Try that in your head. Okay? This is what, no, but this is non-calculator kind of question. So our vertex, 40 over 3. It's much easier to take that fraction and then change it to a decimal after than it is to take decimals and do the math with, especially ones that repeat forever. Have you ever tried to write a repeating decimal and write it all out?
Definitely. No, I just write the little line over the top of it.
This is the max area. Now, if you want to divide that, it's actually easy. Get 533.3 repeated. And this is the x value that will give us that maximum area, 13.3 repeated. It's a good one to practice decimals. What is the dimensions? Well, x is 40 over 3 by, what were we? We were in feet, right? 40 over 3 feet by, what would the other side be? What would the other side be? It's actually easy math with the fraction. Not so easy if you had the decimal. 40 over 3 times 3 is? 40 over 3 times by 3. What's going to happen? Yeah, the 3's just cancel out. So the other side is just going to be 40. Nice number comes out in the end. There's a pattern for this too. So Austin's noticing some patterns. Besides the fact that at the end of the day, he has no chickens left. So Austin is predicting that if he had 100 feet of fence, he's predicting that this side would be 50 and this side would be 50 over 3. So that would be something to check out. So look for a pattern and then prove it. And then you could start with any amount of fencing. This is what a mathematician would do, is if you see a pattern, how do you prove the pattern always works? You can't try every single number, so you add a variable like, well, we were using x already in this one, so a new one, new L or P for perimeter, right? So then you see if it always works out to be that way. Does it always work out to be L over 2 by L over 3? And then you could prove that it always works that way. Then you could use that shortcut. But until you've proven it always works, you still have to show all of this. Okay.